Hi folks, this is 4.7. We're going to be talking about lists and dictionaries. I use lists probably 10 times as often as I use dictionaries, but there are good purposes for both of them. Lists are extremely important in computer science. I don't have it as one of the five fundamental principles, but really lists have a lot to do with variables, so I kind of lump it in with variables. Lists are basically a way that you can store data and get, large storage spaces for data, and then go to that data source and then pull out what you want. So if you're storing customer information or lists of numbers or things like that, it's very important that you understand how to quickly store things and how to quickly get things back. Because once you get past 4 or 5 items, manually creating variables for 100 items is extremely time consuming and inefficient. So that's why we use lists. Lists are also referred to as arrays. So if you ever see the word array, it really just means a list. In Python, it's called a list. In Java programming language, it's called an array. Dictionaries are, they're actually only exist in Python as far as I know. And they're similar to lists, but there's a couple key differences. Again, I don't use dictionaries very often, but there are a couple instances that I've run into that they've come in really handy. Lists is where you really need to focus for this. Okay, so like a string, a list is a sequence of values. In a string, each value is characters, but in a list, they can be any type. So if I type the word hello, that's really, the word hello just contains an H, an E, an L, and an O. But I can only include strings in there, right? If I use a list, I can put any data type in the list, and they can all be in there at once. So in a list, I could have a string, I could have a character, I could have an integer, I can have a float, I can have Boolean, I can store whatever I want in a list, and I can access anything from the list at any time. So each element of a list, it's an item. So basically there's the list of stuff that's in your, or the items that are in your list are they're all going to have a specific number attached to them, and you can access them. Lists are made with the square brackets. Try not to get that confused with getting a string slice. It says empty list. Ignore that square. If you want an empty list, you just put your variable name. Lists are named just like any other normal variable. It's just really a list is really just a variable that contains a whole bunch of other information. So instead of word equals hello, it's my list equals a whole list of stuff. So it's still a variable, but instead of containing one thing, it contains a bunch of things. An empty list is just the square brackets and then closing square brackets with nothing in it. So it's probably easier to understand with a couple examples. If I've got a list called names, so names equals, and then the list opens with this square bracket, Terry, comma, Ian, comma, Graham. These are all strings. They didn't have to be, but they are. There is the first, or the 0th item in the list, which is Terry, and then it separates all the items by commas. So Terry's in quotes, we know that's a string, and that's the 0th item of a list. Remember, we always start counting at 0. And then comma, which is telling it, okay, there's another item. The next item is also a string called Ian, so that would be the first index number 1, so 0, 1. Obviously, Graham's going to be index number 2. There's another comma, and Graham is also a string, and it'll be index number 2. So if I print the list, it actually just prints the entire thing, including the brackets and the quotes. If I print names 1, now that I've included the list name as well as an index, it goes to the list, finds that index, and prints it out. So it knows it needs to go find names, and it needs to find the first element. Remember, the first element is going to be actually the second thing in it, right? Because we start at 0. So if I access names 1, I'm going, nope, that's 0, that's 1. So it needs to print Ian. So the computer programming counting principle is still in play here, just like it would be with strings. Okay, so this is actually a repeat from before. Here's names. It prints out these 3 names, but lists are mutable. So remember when I said strings are immutable and you can't change characters in your string? You can change items in a list, and that makes it extremely flexible and useful. So if I started out with names as a list that had Terry at 0, Ian at 1, and Graham at 2, I can replace any one of those. I can add to the list. I can subtract from the list. So let's say I wanted to add my name to the list, but I wanted to replace Terry. All I need to do is go the list name and then the index of what you want to replace. In this case, it was Terry, so Terry is the 0th element. And then you just put equals whatever you want to replace it with. So this just takes Terry out and it puts Brennan in. So now when I print the names, just like I did up here, it prints the new list. And instead of Terry, you see Brennan. So that's a way that you can replace something. You can also add to lists and subtract from lists and do all sorts of other stuff. Okay, but to replace, you just do the list name, which item do you want to replace, and then whatever you want to replace it with. I replaced it with a string. But again, you can put anything in lists. I could have replaced it with 5.5 or 3 or true or, anything, really. Okay, the word traversing just means going through a list. Okay? So it starts at the beginning usually and goes through the list until it finds what it's looking for. So that's traversing a list, and this is something you're going to have to do in several of your programs. Going through the list and looking for something. Okay? So let's say we've got a list, and the list is 1, 2, 3, 4, 5. Okay, so our list here just contains integers. And then it's 4x, so we're using a looping statement, 4x in nums, which means it's going to start at the first element and then just go through. Okay, now it's not necessarily starting at 1 because it's the number 1. It's starting with whatever is at the 0th place in your list. So it starts at the beginning, goes to the end. This could be hello, goodbye, good afternoon. It would start at the beginning, hello, and then work its way to the end. It just happens to be numbers in this case. So for x in nums, print x times 2. So for each number in the list, that's what this means, for x in nums, for each number in the list, starting at the beginning, going to the back, I'm going to print whatever x is times 2. So in this case, because they're numbers, okay, x starts at 1 times 2 is 2, and then it loops, and now x is going to be the next thing in the list, which is 2. 2 times 2 is 4. Then it's going to go to the next thing, and the next thing, and next thing. So this was a numerical example, but I want to show you that this works with anything. So I'm going to do it with strings instead. So I'm just going to be, I'm going to say my list equals A, comma, C, comma, F. I am deliberately taking letters that are not necessarily back-to-back, Z. Okay, so here's my list, and of course, I have to put square brackets around that, otherwise it's not a list. So if I print my list, it's just going to print the entire thing. Okay, so run it. It says, okay, you told me to print your list, there's your entire list, ACF set. But let's say I try to do a similar loop as I did last time. Okay, so for, I'll just call it item in list. That's very, item in my list, sorry. This is a common variable name to use for item because it indicates that you're going through each of the items. But again, you could have had it could have been called A, B, Z, whatever. I like to call them items a lot when I use my list. Or when I use lists, sorry. So for item in my list, it's going to start at the start and go to the end. I'm going to print item times 2. Now, remember last time I had numbers, so it actually recognized that there was integers, and then it multiplied them by 2. This time, because it's a string, the times 2 means it's going to print it back to back. It's going to print 2 of them. So when I print my list here, when I do this loop, it should print A, A, C, C, F, F, Z, Z. Okay, A, A, C, C, F, F, Z, Z. Right? I just want you to contrast that with what we had before, where it was just a bunch of integers, right? 1, 2, 3, 4, 5. Okay, it recognizes what these are. So if you put a 1 inside a list, it's going to say, I think that's an integer, unless you tell it otherwise. Okay, if I do a decimal, okay, it's going to say, I think that's a float, unless I hear otherwise. If you put quotes around something, it's going to say, I think that's a string, unless you tell me otherwise. So when I run this program, even though there's numbers in here, there's one of them's an integer, one of them is a float. This is a 3, but I put quotes around it, so it's a string, not the number 3. I could also put true as a Boolean variable, and then I'll just leave 5 alone. Now what happens when I print that? Okay. A, C, C, F, F, Z, Z, A, C, C, F, F, Z, Z. I guess I got to print my list 2, not my list 1. I just basically repeated the same thing twice. Here we go. Okay, so this part here is our first for loop in our first list. And the second part, you know what, just to simplify this, I'll just get rid of my original list. And I'll just print the second part. Okay, so 2. So the very first thing it did, it says for item in my list 2, so it starts with the first item. It says, I think that's an integer. Print whatever that was, times 2. So because it's an integer, I can do math with it. 1 times 2 is 2. Then it loops, and then item becomes the next item in the list. So now it's going to be 2.0. Computer says, I think that's a float. So I'm going to take that float, 2.0, and multiply it by 2. And because it's a float, I have to put 4.0. Remember, when it gets more accurate, okay, even though I'm multiplying a float by an integer, 2.0 is a float, 2 is an integer, it always takes the most accurate one, which is always going to be the float. So that's why I printed 4.0. Then item, in my third loop here, item is now the word 3, because I got quotes around it. So when I try to print the word 3 times 2, it doesn't think of this as a number 3, an integer or a float. It thinks of it as a word, so that's why it prints 33. Just like it did with the A, C, F, Z, it prints it twice. So that's why I got 33. This one's interesting. This is a Boolean, true or false or Boolean, right? So when item loops the 4th time and it gets to true, it says, how do I multiply a Boolean by 2? And it's kind of a neat little computer thing. If you have Boolean, true is actually equal to 1, and false is equal to, I believe, -1. So when it tried to multiply by Boolean, it says, because this is true, I think true is 1, so multiplied by 2 is 2. And then 5 was just another integer, so it went 5 times 2 equals 10. I just want to check to see if Boolean false is -1, like I think it is, or if it's 0. I'm pretty sure it's -1. So when I try to run this list again, instead of true, I've got false. I'm thinking this might be -2 next time, but we'll see. 0. Okay, no. So in Python, if you have to assign a numeric variable to something, if I just, printed what's the integer version of true? True is 1, false is 0. So when it got to this one, it said, well, I don't know how to do math with Boolean, because I don't know what false times 2 means. So it says false is actually 0 in this case, and 0 times 2 is 0. Whereas when it was true, true is 1. I'm not sure if there's a better way for me to do that. Let's just say, for instance, I changed this false to quotes. So now it's no longer Boolean. Now it's just a string. Now it'll print false, false. Okay, false, false, because now it's a string. But remember, without the quotes, that's Boolean, and Boolean is actually equal to 0. I'm just going to test something here. Print, let's say I take print true. Okay, so that will probably print the word true. But if I print, let's see if I try to cast this as an integer. The integer value of true, will it print 1 or will it break? Yeah, it'll break. Okay, so I can't print the integer version of true. I don't think it's going to matter what I do. And I assume it also won't print the float value of true. Oh, it will. Okay, so if you print the float value of true, it gave me 1.0. I assume if I print the float value of false, it'll give me 0. And it will. Okay, so that's interesting that you can print or you can convert or cast a Boolean to a float, but you cannot do it to an integer. Oh, no, you can. I must have just had something wrong in I must have missed a bracket or something. Okay, so never mind. It worked both times. I don't know what I did here. I must have had integer. Oh, I had a bracket in the wrong side of int. That's why. That was a syntax error. So you can, if you ever need to find out the numeric equivalent for true, it's going to be 1. And if you want to find the numeric equivalent of false, it's going to be 0. But if you just print true or false, you're just printing the Boolean value of it. Hopefully I didn't confuse anybody with that. That might be a little deeper than we need to go. Okay, so let's go back here. So traversing a list is just going through the list one element at a time and doing something with it. Looking for something or printing something or doing math with something. Just going through a list one at a time. Okay, you can concatenate lists just like you can concatenate strings with a plus sign. So if I have 2 lists, the first list nums is just 1, 2, 3, 4, 5. The second list is 6, 7, 8. If I want to print nums plus nums2, it actually makes a new list. Oops. It makes, prints out everything as one list. If I were to say nums3 equals nums1 plus nums2, that would be a totally new list with all of those characters, and I'll just demonstrate that here. Okay, so we had nums equals, and then we started 1, 2, 3, 4, 5, right? And then we had a second list, nums2 equals, 6, 7, 8, right? So I can print either of those or both of those. Let's print nums, it'll just print 1, 2, 3, 4, 5. I run it. Clear this. Run it. 1, 2, 3, 4, 5. So it's printing the first list. If I tell it to print the second list, it'll print the second list. Okay, 6, 7, 8. If I get them to print nums plus nums2, now it'll print both of them. Okay. I could also do a third option, and I could make, let's just say I've got nums3 equals an empty list. Let's say nums3, okay, equals, and then let's put nums plus nums2. So if I make a third list, I actually don't even need to make it a blank one. If I make a third list and I say I want this third list to be both list number 1 and list number 2, and now I print nums3, I've created a new list that includes both of them, right? Nums3 equals nums plus nums2. So you can concatenate lists. You can put two lists together. You can repeat lists, just like you can repeat letters in strings. So if you have nums equals 1, 2, 3, 4, 5, if I print nums times 3, it actually doesn't multiply each number by 3. It takes the entire list and repeats it 3 times, right? So if I take this list, 1 to 5, and I print nums times 3, it'll do 1, 2, 3, 4, 5, and then it'll do 1, 2, 3, 4, 5, and then it'll do it 1, 2, 3, 4, 5. So beware of that. If you are trying to multiply each number by 3, you're going to have to use a loop. If you just want to print the entire list 3 times, then you don't have to do that. You could slice lists just like you would slice strings. They're very closely related to strings. Remember when we were slicing the word Python or P. Diddy apart? You can do the same thing with lists. So if I want to print only a couple things from the list, or maybe from the midpoint to the end, I can use slicing. So print names, square bracket, starting at 1, going to 3, which we know will only go to 2. So it starts with name 1, okay, Terry's 0, Ian's 1, so it's going to print Ian, and then it's going to print the next one, Graham, and then it knows to stop at the third one. So 0, 1, 2, 3, because I told it only to go to 3, it actually stops before 3. It stops at 2. So just that, quirky little thing about Python where you got to remember these slices only actually go to the number before the one on the end. If I print names to the end, right, that's the blank spot after, if you have a blank after a colon in a slice, it goes to the very end. So it's going to start at 2. So 0, 1, 2 is Graham, and it's going to go to the end, and Brennan's the last one. So that's why you get that. If you print names -3 to 0, or -3 to basically nothing, it starts at this place, and it'll go to the beginning, right? So, it'll go to the end. So if I go -3, that is -1, -2, -3. -3 is Ian, and then it's just going to print to the end. So in this case, -3, so -1, -1, -2, -3. -3 was Ian, but Ian is two things, right? Ian is both 0, 1, Ian is both 1, and Ian is -3. -1, -2, -3. So I could print 1 to blank, and I would get the exact same result here. It's kind of important to remember that in a string or in a list, each of these has 2 different numbers associated to it. Like Terry is 0, but Terry would also be -1, -2, -3, -4. So Terry would be 0 and -4, Ian's 1 and -3, Graham is going to be 0, 1, 2, or -1, -2, and Brennan's going to be 0, 1, 2, 3, or -1. So there's 2 ways of getting there. You can start at the start, you can start at the end. You can add to the end of the list with append. Let's say you didn't want to replace, you just wanted to add my name. The first time I did this, I replaced Terry with Brennan. Okay, but this time if I want to add a name to the, and it automatically goes to the end of the list, you can use the append. So it's names, and then here's dot notation, names dot append Tim. So now it just adds Tim after Brennan in your list. So you can just keep adding things to the end of your list. You can remove an element with pop, P-O-P. So names dot pop, and then you have to put in regular brackets which element you want to pop out. So in this case, they're popping out element number 1, so that would be Ian, right? So if you do names dot pop 1, you're popping out the first element, which would be Ian, because Terry's 0, right? So Ian's number 1, so it just pops Terry out, and now we've got left, or pops Ian out, sorry, and we're left with Terry, Graham, and Brennan. And it also reshuffles the numbers of these, right? So Terry is still 0, but now Graham's 1, and Brennan's 2. Okay, so whereas before Graham was 0, 1, 2, and Brennan was 3, now because we popped Ian out, these two just shuffle over and they get new numbers, new indices. If you forget the index number, like for instance, this one we popped out 1, which was Ian. If you forget what you need to pop out or you want to pop out based on what's in there, you use remove. Okay, so when you remove something, you don't remove a number or an index, you remove the actual values. So names.remove Ian, searches through the list, oh, there's Ian, Ian's got to go, and then it shuffles the others over, just like it did before. So that's the difference between pop and remove. Pop uses the index number, and remove uses what the actual value is. You could sort them with .sort, and there's also a reverse sort. So if I go names.sort, these are all names, it's going to sort them alphabetically by the first character. So if I sort the list, and then I print the names, B comes before G, comes before I, comes before T. One thing you need to know in this is that it matters what the case is. So if I go to Thani here quickly, and let's make a quick list. So my list equals, I'll put them in any order. I'll put K, lowercase k, I'll put uppercase K, I'll put a lowercase a, I'll put an uppercase a, and I'll put a lowercase c and an uppercase c. Okay, so there's my list. As usual, I forgot to put square brackets around it. There's my list. It's not in alphabetical order. Okay, but if I do my list dot sort, okay, it has sorted my list now, but watch what happens when I print it out. So if I print my list, watch the result I get. Okay. Capital A, capital C, capital K. So you might look at this list and then logically, based on what you know of the rules of English language, you would probably be more likely to put, maybe capital A, capital C, capital K, little k. Okay, but all of the capital letters have lower ASCII numbers. Remember we went ASCII numbers? And that's what it actually sorts them by. So if you remember the strings unit, I said that little a is actually equal to the number 97 in ASCII, and I said capital A is equal to the number 65. So when you sort them, it actually doesn't sort the letters, it sorts the ASCII characters that represent the letters. So this is 65, and then B would be 66, C is 67, okay, and then all the way to K, and then when we get to A, the lowercase, it's actually 97. So that's why 65 and 67 and whatever K was printed all of these before the lowercase. So it's always uppercase first and then lowercase. So the number was 65, this one was 67, and then eventually we get to the lowercase a, this was 97, the lowercase b is 98, c is 99, right? And then all the way down to k. So just be aware of that when you're sorting like characters or words. The case at the beginning of the case at the beginning of the string or the character matters. For instance, oh, by the way, it checks the first character, then the second character, and then the third character. So let's just say we have, let's just say we have Brennan here. We've got Bren with two N's, and we've got Brennan. Okay, now how is it going to order these? Okay, because the first character is the same in all of them, so is the second, so is the third, so is the fourth. So you need to know that when it's sorting the list, maybe I'll just put this in a slightly different order. When it's sorting the list, it starts at the first character, but if it doesn't find any difference, it goes to the second character, third, fourth. So it doesn't know how to sort these until it gets the fifth character, because the first four characters are the same. As soon as it hits the second N, then it knows that there's at least a difference between these two. And then when it goes to the A, then it knows there's a difference between all three of these. So when you sort your list, okay, it doesn't just take the first character. It starts there, then it tries the second, tries the third, tries the fourth. So this would be the correct order. Bren would be alphabetically before Bren with two N's, and which would be alphabetically before my full name. So it takes care of removing and sorting. You can cast a string as a list and makes each letter an item in a list. Now, I don't do this very often, but it is kind of handy every once in a while. If you've got a string, say my name, and you put in list and then brackets name, it'll actually take this name and make a list with each character being its own item. So we'll just demonstrate that quickly in Thonny. Okay, so if I've got name equals Brennan, okay, currently if I print name, it's just going to print Brennan, right? Because that's Brennan. But if I wanted to convert this to a list, so maybe I needed to access each letter individually for some reason, and I wanted it in a list, I can make a list. My list equals, and then if I put list bracket name, it's going to create a list based on this string, but it's built into Python that instead of just putting the whole word Brennan as the first and only thing in the list, it takes each character and does it. So so when it prints my list here, okay, so it's going to print my name, then it's going to create a new list, okay, with the list command and name, and then it's going to print my list. So it's going to print my name, then it's going to print, at the end, it's going to print the list. You can see each value is separated by commas. So B would be the 0th element, R would be 1, and B would be 2, etc. That's a list. And I showed you that you could add names to lists, you could append lists. So let's, instead of, what would I do here? I'll go through and print each item using a quick loop. So for X in, or item in my list, so it's going to start at whatever the first item is, and it's going to go to the rest. Let's print, okay, let's print item. So this is going to go to the first item in the list, which is going to be the B. It'll print the B, and then the next time it loops, it's going to print the R, then the E, then the N, etc. So if I run this, and print for item in my list, print item. Let's give me on here. My list is a list for item. Capital F. There we go. So this Brennan was just from before up here. Get rid of that, run it again. All right, so for item in my list, print item. Because I converted the string Brennan into a list where B was the 0th item, R was the first item, E was the second item. Now I can run a quick loop on my list, and I'm actually traversing my list because I'm starting at the beginning and I'm going to the end, and I'm just printing each item as I come across it, right? So if I print my list above here, it makes it a little bit more obvious, right? As soon as I converted the name into a list, this is the entire list, and when I ran the loop, it started at the beginning and then just printed out each element as it went through. And when it got to N, it knew it was at this end. It knew it was at the end of the list, so that was the last thing it printed. So that's an example of how you take a string, you turn it into a list, and then you traverse the list and access and print every item. You can split a string with spaces into words in a list. Okay, so if we've got this is a sentence, you can make a new list equals sent.split. That's kind of neat because this is sent, okay, is a list already, and it's only got one item in it. It's just got this is a sentence, which is a string. But if you split it, okay, this split command will automatically make a new list. That's what split does, and it also splits everything by spaces. So if you have a list and you go list.split, okay, it'll split each of these into its own a list with as many elements as there are spaces. So for this item, this would be item 1, is would be item 2, a would be item, this would be item 0, is would be item 1, a would be item 2, sentence would be item 3. It does not make list for the spaces. It just uses the spaces to split it. So again, let's go to Thonny and let's do an example of this. I'm just going to make it the same thing. I'm just going to be, maybe I'll say sentence equals this is a sentence, period. Okay, now I want to make a new list, so if I print that, right, let's just print sentence. So if I print sentence, the obvious happens. This is a sentence that prints out. Right? But let's say instead of printing it, I want to take this string and I want to split it into a new list where each element is separated by a space. So I could say now my list equals sentence dot, okay, it's dot notation, split. And by default, it splits. By default, it splits using spaces, but I'm going to show you how you can change that after. So now if I print out my list, okay, it's going to print out what the list is based on splitting this sentence by spaces. So now when I print it, okay, when I print my list, you'll notice that it broke up the string, this is a sentence, and made it into a list with 4 items in it. This is the 0 item, 1, 2, 3. It didn't include any spaces. Okay, there's still only 4 items in your list because there's 4 words in your sentence. I'm going to show you now how you can split based on something other than a excuse me, other than a space. Okay, split by default does space, but you can play with that. So you can use any of these are called delimiters, and it's just means what do you want me to break up this string with, and it could be anything. So if I have this is a sentence with dashes, and I say split, and then instead of not having anything in the brackets, I put the little dash here, it'll do the exact same thing. So if I flick over to Thani here, and maybe I put this star is star sentence. So now if I try to split my sentence without changing this, watch what happens. Okay, it still made it into a list, but because it looked for blank spaces, it looked for white spaces and didn't see any in here, it said, well, I guess that's only 1 item. So your entire list is just 1 item. This is a sentence. Okay? But if I split it, and then I put in the character I want to use to split it, in this case, a star, okay? Now it's going to say, every time I see a star, I know that this needs to be another item. And there's another star, and there's another item. So every time it hits a star, it's going to say, that's a new item in my list. Okay? So now I didn't have spaces in this, but because I had stars and I told it to look for stars, I ended up with the exact same 4-item list. All right, dictionaries are like lists, but they're more general, and they use a key-value relationships. They're called dictionaries because they act just like dictionaries. It's a word and a definition, but it can be any data type. So we know that lists are defined or assigned using the square brackets. Okay, dictionaries are assigned with braces, which are, they're kind of the squiggly brackets. They're up by the enter. They're on the same key as the square brackets. Okay, empty dictionary, just empty braces or empty squiggly brackets, whatever you want to call them. All right, so like I said, it works as a dictionary. It works with key value relationships. So if I just make a new dictionary with curly brackets and I put string 1 colon uno, and then comma. Comma is how it tells what a new dictionary item is. So for this one, the first 2 things here are just 1 dictionary item. So what we're doing here is we're just taking, I guess this is Spanish, isn't it? We're taking the word 1, and we're saying that is related to, that's what the colon is, okay? That is related to uno. So 1 is the key, and uno is the value. So this is all sort of 1 dictionary item. Then you've got a comma to represent there's going to be another dictionary item. This time, 2 is the key, and dos is the value. And then you could keep going, 3, tre, what is it? Uno, dos, seis, cinco, seis. Basically, though, we're just doing these numbers in a different language using a dictionary. So if I print new dictionary with square brackets, and then I have to put the actual key in. So the key is 1. It doesn't print 1. It says, I need to find 1. Okay, now I need to print the definition. Okay, so once it finds the key, it knows to print the value. So I told it, look in new dictionary, look for the key 1, and print it. So I looked from the dictionary, I found the key 1, it finds the value, and it prints the value. If you print the entire dictionary, if you don't have these little square brackets, if you print the entire dictionary, it prints everything. It prints key value, and then key value, and then key value, depending on, how many things there are in your dictionary. So you can use the in command. Remember how we checked if a letter was in a certain word? You can use that in dictionaries too. So we've got the same dictionary we had before, and you could just say, print print 1 in new dict, and it'll print true because 1 is in the dictionary. Uno in new dict is false because it only checks the keys, right? So it only checks, okay, when it checks something, it checks, is it in the key? No. Then is it in this key? Nope. Then I'm done. Okay? It doesn't check the values, it only checks the keys. That's why 1 is true, but uno is false, because 1 is a key and uno is a value. If I had checked, is 2 in new dict, it would also give me true, because 2 is in the key spot. If I checked if dos was in the new dictionary, I would get false again, because dos is in the value. Dot values can be used to check if a value appears. So this is how you check keys, and then dot values is how you check values. So is uno in new dictionary dot values, then instead of checking these ones, the keys, it goes and just checks the second part of every one. So you can search for either keys or values. All right, this is, this is a reasonably difficult assignment, but give it a shot anyway. What I want you to do is I want you to create a dictionary that will be a code. It'll be a cipher. So you're going to take the dictionary, and these are going to be the keys. Okay, A to Z are going to be the keys, and the values are going to be the alphabet shifted by 3 letters. Okay, so A, instead of being A, it's going to shift 1, 2, 3. It's going to shift B, C to D. So it's going to shift 3 characters, and it'll be a D, which means the B is going to be an E, C is going to be an F, and so on. When you get to X, then it's A, Y is B, Z is C. It's not it's not gonna fool anybody. But what I want you to do with this is I want you to have a program that takes a word, prints out the encoded version of it, okay, and then maybe prints it back regular again. So I'll just give you a second to stop the video and go try that. I want to be able to put in a word or a sentence, and I want this program to automatically give me the encoded version. Okay, you should use a function. Use it. Get used to using functions, and it should be a fruitful function. So make sure you're using return. Okay. So pause the video, go do that, and now I'm going to go and I'm going to show you how I would have done it, and hopefully our versions matched. Okay, so I'm just going to cipher. That's just my variable name, equals braces, and a lot of times people will do stuff like this when they do their dictionaries, just to give you a little more space and not cram it all into one line. So my dictionary, my first item is going to be A, and then colon. What is A actually going to be? It's going to be D. So my key is A, my value is D, comma, okay? And you can do them sort of all the way down here like this. Now B is going to be E, right, comma, what am I at, C? C is going to be F. You don't really want to watch me type for 5 minutes, so I'll pause it and I'll turn it back. Okay, I'm back. So I created my dictionary, called it cipher. Key A is equal to value D. Key B is worth value E. I just did that with the entire alphabet, right? So A to Z in this key column, and then in the value column starts at D, gets to Z, and then wraps around and starts at A, B, C again. So all the letters are represented in both of these sides. Okay? And the whole point of it was to shift things 3 places so that anything that was an A is going to be a D. So if I want to print out my cipher, okay, so I'm just printing my whole dictionary. Okay, it'll show you, okay, A is D, comma, so it's next item, B is E, C is F, etc. Now if I want to use this, let's traverse this cipher and then print out basically the encrypted version of the word. It's not a very strong encryption, but it would be encrypted nonetheless. So let's do def get, what do we want to call it? Get encrypt. Okay, so actually I'll just call it def encrypt. And what am I going to send it? I'm going to send it a string, okay? And I'll just call it A for some string. All right, so our definition, or sorry, our function here, what's it going to do? It's got to traverse through this entire dictionary, okay? And then it's got to replace each letter with the value of that letter. So for, we know we need to traverse it, so we need to do for letter in A. So A is going to be a string, right? We don't know how many letters it's going to have. So every time it hits a letter in A, what we need to do is if the letter in, what did I call my dictionary again? Cipher? Cipher. Okay. So if whatever that letter is, that you know, it's the first letter in the string, okay? If that letter is also in the cipher, remember it's only going to check in the key side, so it's only going to check on the left side here. So if it's in that cipher, I want to, I could print it out and it'll print one letter per line, but what I'm going to do here is I'm just going to create a temporary string so I can just keep adding to it. So I'm just going to call this temp string equals nothing. Okay, and then if the letter is in the cipher, I'm going to go temp string plus, okay, letter. Not plus letter, plus equals letter. There we go. So this is just going to take your temp string and it's going to add one letter at a time. And then when it's done, okay, when it's done all that, I want to return temp string. So when it's gone through the entire word and replaced all the proper letters, temp string is adding one letter at a time, okay? Then we need to return temp string. So I said if letter in cipher, temp string plus equals letter. What I really wanted to do was plus equal whatever the key was in here, right? So, or the value in here. So, you know, if the first letter in the word is A, I need to add D to the temp string. So I need to access that. I need to access the value of it. So I need to do my what did I call it? Cipher, sorry. Cipher. And then what do I need to reference within the cipher? Letter. Okay. And what that's going to do is it's going to print out the value. So if the letter is A, okay, it checks, is the letter A in the key side of cipher? And it goes and it says, oh, there it is right there. It's in the key side. So what I want to do is I want to add the cipher of A, which means basically the value of A. So here's cipher A, I'm going to add D. And it's going to keep doing that for all the letters. It's going to check, is there a V? Okay, I'm going to add a Y. Is there an R? Okay, I'm going to add a U. And then when it's done checking, temp string theoretically should be the entire word, phrase, or sentence that has been converted to our encrypted version. So I'll just return the temp string. So returning it makes this function from a void function, it makes it actually a fruitful function, which are the ones we like to use. So I'm going to print, or I need input first, sorry. Okay, I'll just put A equals nothing for now. So I need to get something for A from the user, right? So I need to do A equals input, and it's going to be a string by definition. Enter a word or phrase. Okay, and then I'm going to call the encrypt function. So I'm going to print, and then I'm going to call the encrypt function, encrypt. And what does encrypt mean to work? It needs whatever word or phrase I created. So I'm going to send it A, and then I'm just going to call this a word, because I don't like to have the parameter be the same name as, or sorry, the argument be the same name as the parameter. So a word will just be A. Okay, so if I send it, whatever the word or phrase is, it's going to go through whatever that word or phrase is. It's going to replace, okay, all of the letters, okay, with the new letters on the right side, and it's going to add those to temp string one at a time. When it's done, when I return temp string, what did I want to do with this whole encrypt A process? I just wanted to create the password. So at the end of the day, I'm printing whatever the result of encrypt A was. So the result of encrypt A is going to be temp string at the very end. So it's going to send temp string back, and it's going to print temp string. Okay, so let's just see how that works here. So enter a word or phrase. I'll enter hello. And then, of course, it gives me an error. Temp string plus equals cipher letter temp string reference before assignment. Temp string equals, temp string. Oh, no, that's fine. Temp string, encrypt letter, words. There's some sort of syntax error. It's giving me a problem. Temp string plus equals cipher bracket letter. I think maybe those need to be round brackets. That might be the issue. Yeah, still doesn't like it. Local variable temp string reference before assignment. Temp string, return temp string. Temp string is nothing. Nothing. Cipher in there. Encrypt a word for letter in a word letter in cipher. Not liking temp string. You know what? Because I only need temp string in my... I've got it as a global variable up top here, but because I only need it inside this function, I might just make it inside this function. So temp string equals nothing. Let's see if that still gives me the same error. Still did. Dictionary option object is not callable. Okay, so I made a mistake in here somewhere. Cipher, I spelled that right. Cipher, okay, that's dictionary. If letters in cipher, temp string, add the cipher letter. I think it's something right here. I'm just going to check and make sure my syntax is correct. When I am accessing print one uno. Oh, no, I need the square brackets. Print immediate one. Yeah, I need square brackets. Did I not have that before? Cipher of letter. Temp string plus equals cipher of letter. Letter should be this side, which means it's going to print the other side of this. I'm just going to comment this out just for a second, and I'm just going to see if it's going to print. It's all the troubleshooting I love doing. It can be frustrating at points, but I tell you, when you get the right answer, it's really satisfying. I'm just going to print cipher letter to see if I get any data. So hello, K-H-O-O-R. I know exactly what the problem was. I had a capital letter, and I don't have any capital letters in here. I was putting in capital letter for H. All right. Well, that was a silly mistake. Okay, let's try this again. Instead of a capital hello, I'll put in, there we go. That was a silly mistake. So I guess if you wanted to have a really good cipher, you'd probably have to include all the capital letters as well. So your dictionary would be twice as long. You'd have to have all the capital letters. So this worked. It took hello and it changed it into K-H-O-O-R. It will also work if I put multiple words in. What it won't do is find spaces, because I didn't tell it to find spaces. If I wanted to do that, it's really simple. All I need to do is add to my dictionary a space, and then say a space still equals a space. So that'll actually take care of that as well. So now if I want to, I'll clear this out. Oops. How did I do that? Out of the plotter somehow. Oops. And I'll clear this, and now I'll just run it again. I'll put some spaces in. So hello there. Welcome to computer science. I didn't put any commas or periods in either, so I'll do this without punctuation. And did it not run? Should run. Welcome to computer science. There it is. So this is welcome to computer science in a Caesar cipher. So it's basically, if you sent this to someone and said, hey, take each letter and go back 3 spaces, they could take this encrypted message and then translate it back to welcome to computer science. So the whole point of encryption, and this is like encryption from 3,000 years ago. But the whole point of encryption is that you encrypt something and make it unreadable to normal people, and then you can decrypt something on the other side, but you have to know what the trick is, right? So if I convert welcome to computer science to this, you're not going to know what this means until I tell you, hey, you got to take each letter and go back 3 in the alphabet. If I tell you that, then you can go letter by letter, go, oh, okay, this really says welcome to computer science. If I don't tell you what the trick is, you're not going to be able to decode it. So every encryption has a decryption process. There are programs to break codes that would break this in about one millionth of a second. If you want to get more into decryption and encryption, it's really, really interesting. It uses a lot of mathematics, a lot of discrete mathematics, and it looks for patterns. It does really good things. Like it knows the E. The E is the letter that is most used in the English language. So if you had a code and you were going to try and break it, and you knew it was letters, but you didn't know what letters were each. Well, if you counted all the letters, whichever letter had the most in the encrypted version, that's probably an E. And then it would look for the next most common. And it might not break the entire code all at once, but you'd have a much better idea of what it was trying to say if you managed to put in like 90% of the letters based on how often they're used. So there's really cool little pattern searching things that computers can do. And again, the using I can't even remember what it's called, but checking the frequency of the characters and trying to break the code that way. That's juvenile. That people were doing that before computers, but just one of those interesting ways that you can protect data and hack data. People create security systems, and then other people are paid to break them, either for criminal good or because they're testing the company's products and want to make sure that their security works. The type of a data encryption that we have today, WEP and 132-bit encryption and things like that, is essentially unbreakable. When people's databases are compromised and information is leaked to the public, it's usually not because somebody has, quote, cracked the code, unquote. Usually they've used social engineering to get somebody to give them a password. That's what cyber hacking looks like in the new day. It's not so much, hey, I built a program that cracked your password. It's more like, I found a way to get you to tell me your password, or I found it in an email, or I talked to you on the phone and convinced you I was somebody that I wasn't, and that's how I got your password. It's called social engineering. So social engineering is responsible for many, many, many more data breaches than is actual hacking with programs and data. But that's an aside. Anyway, so that should take us to the end of lists and dictionaries. And I don't think we're going too much further in Python. So practice all your skills, do the assignments, do all the coding bat assignments, and work on your individual projects. As always, email me if I can help you.